Alright, so we're going to be starting what I would have considered the 14th problem, but it seems like the Grind 75 breaks it up into weeks and restarts the count at each week, and that can even change depending on how many hours and weeks you give yourself, but I'm just going to give the problem name and keep increasing the count regardless of the weeks and hours that we put into our schedule. So I'm going to call this problem number 14 from the Grind 75. This is implement queue using stack. We are going to take 20 minutes to do this problem, and so let's start right now. All right, let's see. So implement a first in, first out queue using only 2 stacks. The implemented queue should support all the functions of a normal queue: push, peek, pop, and empty. Okay, push, peek, pop, yeah. Implement the myQueue class. Void push pushes the element to the back of the queue. Pop removes the element from the front of the queue and returns it. And peek returns the element at the front of the queue. And boolean empty returns true if the queue is empty, false otherwise. Okay. You must use only standard operations of the stack, which means only push to top, peek, pop from top, size, and is empty operations are valid. Depending on your language, the stack may not be supported natively. You may simulate a stack using a list or DQ, double-ended queue, as long as you use only a stack's standard operations. So let's see. Your myQueue object will be instantiated and called as such. Push pop peek is empty. Okay, let's see. Using stacks, okay, so let's take a look at some examples. The input is instantiate. Going to push something to the queue, and then we should pop that, or I guess we're going to peek and then pop and empty. So okay, I guess this is our input. Hold on, this is, so we're gonna push null and then push 1 and then peek at our first one should be null and then pop that first one. Okay, now let's look at the explanation. So instantiate my queue. We're gonna push 1 and push 2. Leftmost is front of the queue. That's right. Okay. Peek just returns 1. Pop also returns 1, but then it removes it, and then is empty is false. I guess, okay, I see how that works. I'm not going to worry about the follow-up right now. Let's just think about the implementation. So using only 2 stacks, okay. So stack may not be supported natively. The stack is supported natively in Java. Let's think about, so there is push, pop, peek is empty. I'm just going to actually write that. So for Java, push, pop, peek is empty is all supported. Let's see. We're going to want to use 2 stacks, so let's go to the drawing board and think about how we could do that. So I'm going to switch over right here. So a good way to think about a stack and a queue actually is you could make it as a linked list, but I'm actually going to just make a physical stack. So um, so this is going to be a stack, and we're going to have 0, and then 1, and then 2. Okay, so we start here and we add for the different methods. Push, we're continuously pushing on top. For pop, we would also take off the top like that. For peak, we look at the current top, which would now be that, and is empty. It's clearly not empty. However, for a queue, when we add something, the first item we add is going to be at the front like this. And then the next item we add is going to be after that and after that. So when we push to the bottom like this. When we pop, we remove off the top. So the abbreviation that is commonly used is that, and the abbreviation for this is that. Where the first one that we added, 0 in this case, is the first one that's out, and the last one that we added, in this case 2, is the first one that's out. So that's really just to convince myself I know the difference between the two. Let's think about how we would use 2 stacks to implement a queue. So let's see. Again, these are the operations that we want to implement for the queue. Let me go back a little bit. It is deep. So let's see. Okay. So we're adding values to the stack. Say we want to pop. The second stack, I guess, could just take everything that's in here, and that would reverse it. So we would have to remove this entire stack that we've been pushing. We might not necessarily have to do that, but let's just go with it for now. And then we'd rearrange it into the second stack. And then from there, we can pop, peak is empty. Okay, but what if we have the operations nested within each other? Well, not nested, but like interwoven, for example. So say all we've added is this 0, and then we want to peak, and that should be okay. I think 2 would be a little more representative. So say we push twice, and then we want to pop, we want to peak, we want to ism. So let's see, after every push, do we just automatically, So let's just get a chain of events. So say we're gonna push, push, pop, maybe push and pop and pop. So we're going to push 0 and 1. As soon as we want to pop, we're going to put it into our second stack by popping off of our current stack and then adding it. So the last one in is the first one out. Yeah. and we have to perform the pop operation. Okay. And in this case, since we popped everything off of here, this would also be empty. So just gonna get rid of this really quick. And then we're going to push again. And then we're going to pop. That means we're going to pop everything off. And then push it to the stack. Should be 2 now. Is that right? The last one in was the first one out. Does that hold up though? Because, no, it doesn't seem to. Because on the stack, the last one in, the stack goes on top, and then we pop off the top of the stack. So push, push. We can't add underneath, that would be like a queue. So let's see, would we alternate? So we have 2 in that original one, and then we want to perform the push operation, and we were thinking that we would add it to we would add it to our second stack, but it seems like this value would actually have to go on top of this one. So let's think about this for a second. Okay, so I think we have about 8 minutes left. So, okay, let's really try to get this going. So 2 stacks. Let's think about the operations we have to do. So following this chain of events, if we push twice, 0, 1, and then the first pop, we pop everything off of the first stack and then push it all into the second stack. And then we can push to the first stack again, but as soon as we pop, if there's anything left in the second stack, then we pop that first. Otherwise, we are going to take out everything that's here. If that's empty as well, then we should return nothing. I guess return null. So that would be, so the push operation will always just add to the first stack. So let me switch over to, 1 second. I'm going to switch over to the LeetCode window again. Let's go now. Okay, so my queue. So for my notes right here, so the push is simply going to stack 1.push. The pop is going to handle a lot of the logic. So let's actually do this. So pop, what is that going to do? If something in stack 2, pop that. If else if stack 1 is not empty, push pop everything off of that and push to stack 2, else we'll have to return null, because that means that our queue is empty. So that's pop. Let's see. The other one should be fairly straightforward too. So we have peak. That will have to perform a similar operation, this popping off. So we can actually make another function. Let's call it push to 2, and that basically pushes everything from stack 1 to stack 2. And that's going to be used by the pop method, and it's also going to be used by the what is it called? Peak method. So it's going to be pretty similar to pop, actually. Except we're going to peak instead of pop everything off and push to stack 2. This will now just be called push to 2. And for is empty, our queue will only be empty if there's no value in circulation. What I mean by that is that it's not in stack 1 or stack 2. So is empty is just going to be probably this exact line. Return stack 1 dot is empty and stack 2 dot is empty. So I'm actually just going to copy them, put that up here for that, semicolon. My queue, it's going to have a stack. What are we going to have? Our elements are going to be integers, so we can just say stack integer is equal to, or let's say stack 1 is equal to new stack integer. So it's going to be empty at first. We'll have the same thing, except we're going to call it stack 2. And all right, let's go over push. Push is just going to take this and add it to stack 1. So I'm not going to return anything, so all we're going to do is stack 1 dot push x, and I am going to want to create that function push to 2, which will also be void, but it's basically going to take everything that's in the first stack and push it to the second stack. So we could say while stack 1 dot is empty is false, we're going to say int new entry is equal to stack 1 dot pop, and we're going to stack 2 dot push new entry. Okay, so let's go over the pop logic. If something, so if stack 2 dot is empty is false, meaning that there's something there, and that means, and the timer's pretty much done, but we're almost Done. So, okay. If stack 2 is empty, or it's not empty, that means there's something there. That means we're going to want to push off the value that's there. So we're going to return stack2 dot pop, because stack2 is ordered in the way that we would like the queue to be ordered. Else, if it's the case that what? Else if there's values in stack 1, stack 1 is not empty, then we can push everything. We can call push to 2, push to 2, and then we would call pop again. This class is pop. And yeah, okay. But else, if everything's empty, then we should just return null. I mean, we could also just call this function, but that would be, well, this function is supposed to return an integer, so let's just leave it as null. This is going to have a similar logic, so I'm just going to copy paste for peak, and instead of pop, we're going to peak, and then we're going to call peak again, and else we should return null. Okay, that seems about right to me. Let's see. Okay. Pretty straightforward. There might be some cases that I'm not accounting for. Pop and peak are valid. Okay, so then that means we must have this null return value. Let's run the test case and see if we pass. There's probably some syntactical error somewhere. Yeah, let's see. Stack1.push. Okay. Cannot find symbol. Let's see. Oh, I didn't. Let's see. There should be like my queue. Oh, okay. Yeah. So we can't. We shouldn't be using these objects exactly. We should be calling them on queue objects. So let's see. I guess we'll just have to dot into them. So each queue object will have this stack 1 and this stack 2, but I believe we just have to say this instances stack 1, and we have to pretty much put that in front of everything. Let's see. Okay, did I miss any? Okay, let's try running this again. Okay, that didn't really fix it. Mm, I'm missing some sort of syntactical thing somewhere. So we have a queue object. The first thing that we do is create a new queue. Oh, when we call dot push. So when we call dot push, we want to take this object's stack. See, I don't see. We should have that, shouldn't we? Why is it that we don't have it? This instances stack one. I feel like I'm missing something really simple. I am going to actually stop right here for the sake of time. I believe the solution is going to be something pretty similar to this. I'm just missing something in terms of creating objects, creating my own object. So we're going to stop here.